All right, so 5-3, we covered the first of what will be 5 ways to prove that two triangles are congruent. So that's the first of your shortcuts, which is side angle side, right? You need two sides, two pairs of sides marked as congruent, and then the angle where those two sides meet. So this triangle, it says, what can you conclude about triangle PTS, which is the top one, and RTQ? And what's the answer? Are they congruent?
Obviously.
Yes, and why?
Same side.
It's side angle side, but as it's marked, you just have your two pairs of sides, right? That extra piece of information that you know is what? This angle would be congruent to this angle, and my reason would be vertical angles theorem. So if it had turned it into, because they are going to get turned into, not side angle side, sorry. They are going to get turned into proofs. So obviously you want to make sure you know how to justify those steps. Honestly, the fact that there's only one on this quiz, like where we're at now, it should make it a lot easier. When we get to test, you're going to have 5 different ways to prove that they're congruent, so it makes it a little bit more. On the quiz, there's 1 open-ended.
Okay.
Yep.
And how many questions?
10.
You should give like a word
10.
bank to the.
Thank you for your feedback. Your suggestion has been noted. Yeah. All right. This one says, state a third congruence that would allow you to prove that triangle RST is congruent to triangle XYZ by the side angle side congruence. So if for number 2, it gives you that ST is congruent to YZ and RS is congruent to XY. So what would that third piece of information need to be, Mars?
RT is congruent to XT.
That would be if you're doing side, 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 right? So what are you missing here?
S is equal to Y for the angle.
Good. Angle S would be congruent to angle Y. So you're looking for that third piece that would make it side angle side. Number 3. Oh, go ahead.
Right. So the angle is always the one.
Where the two pairs of sides meet. Yep, that's the included angle. All right, for 3, it says, I should have done that first. So we needed S is congruent to angle Y. For 3, it says angle T is congruent to angle Z, and RT is congruent to XZ. So what's that last piece of information? Mars?
T is congruent to Z.
No, I need what do you have already? You have a pair of sides, right? And the pair of angles, so I need the other pair of sides. Sophia?
That ST is congruent to YZ.
Good.
Oops. I got it now.
Okay, good. And it could not be SR and YX because that does not meet at the angle that was given to you, right? We need it to be that included angle, so it has to be specifically that side. Questions? So the quiz review, which your quiz is going to cover 4-1, 4-2, 4-3, that one lesson that we did with all 3 of those put together, and then 5-1, 5-2, 5-3. So 4-1, technically, like this is how they were separated out. We did them all together, but 4-1 is your translation, which is the slide. So you should be able to either graph points with a translation or give a rule, like identify what it would be based on the graph. So in the box that's here, right, this would be here. If I give you the translation, update all those points, you could do that. Or you could be given the actual graph and you have to come up with the rule. Yeah.
Would you happen to know if there would be any proofs in chapter 4?
No. Like, you mean, did we do any proofs in 4-1, 4-2, 4-3? No. No.
But only in 5.
In chapter 5, we did proofs. Yes. Yeah. All right, so you're welcome. Questions on the slide or the translation? So again, you can see those 2 types of questions. Here's the actual translation, or find the rule based on the points, or find the rule based on the graph. In 4-2, you had the reflection. So this is where you're going to get given a line, and you want to draw that line and you want to reflect it. So in this case, it was like the y equals x line. You draw the y equals x, and you use the graph to find the other points. So reflections, it won't ask you for the rule. It will just give you what the reflection is, and then you're going to have to graph it, okay? So for like something like 7, you're going to graph the line that's x equals 4. which would be a vertical line, and then reflect all your points. In 8, you're going to have a line like y equals 3, which would be a horizontal line, and then you're going to reflect all your points. And then 4-3 was your rotation. So you need all of the rotations. So that if it is 90-degree rotation, that you switch the order and you change the original y, which becomes the new x. If it is a rotation 180, you change both signs. And for a rotation of 270, you switch them. You change the sign on the original x, which is now the new y. So for rotation, you need to know how to do that from the actual points, okay? Like they're given there. For 10, I would take if it's rotated 90 degrees, you're going to switch the orders on all of those and then change the sign on the new first one. Santi.
Let's say like it rotates 180 degrees. If it's already negative, would it turn positive?
Correct.
Okay.
So the negative there just means change the sign. It doesn't mean it has to be negative.
Okay.
Yeah. You're welcome. Any other questions on rotations? Okay. Then came chapter 5. So 5.1 is like hopefully some easy stuff. Classifying it, right? So we need to classify by angles and sides. So by angles, you've got acute, obtuse, right, equiangular. And by sides, you've got scalene. Good. And equilateral. And remember that by definition, an equilateral is also isosceles, but if you're identifying it, the better option is equilateral.
So why can't you use isosceles?
Because the better descriptive part would be equilateral. It is specifically equilateral. So if all 3 sides are the same and you give me isosceles, I'm going to take some points off.
So then when would you use isosceles?
If it was only 2 sides the same.
Oh.
So equilateral is equilateral and isosceles, but if it's asking you to classify it, I wonder what that's like. I think it's so interesting that he's annoyed that you're answering the question when normally Santi's very helpful and answering all of my questions for me. Yeah. All right, then came the measure of the angles inside a triangle, which we add up to 180, and the exterior angle theorem that said that the exterior angle is the sum of the remote or non-adjacent interior. Okay, that's like 1, 2, and 3 have exterior. And then came congruent, so this was 5.2, the congruent any kind of polygon, so it wasn't just triangles. Congruent polygons have all sides that would be paired up and all angles that would be paired up. So there's no shortcuts for like a quadrilateral or a pentagon. You have to show that all of them are congruent. But then we got into 5.3, which was now the shortcut for the triangle, which is that first one is side angle side. Okay, questions for me on what the quiz is covering or anything like that? Yeah.
Would we ever have to prove, like, whether or not the 4 angles in quadrilateral are equal to another quadrilateral?
If you were trying to prove that those 2 were congruent, you would need to know that all 4 pairs match up.
Would we ever have to prove that?
Not like in a proof like that. No. Like you'd have to be given that information in order to say that they are. Yeah. And the sides too, yeah.
Is this like a good review for the quiz?
Yeah. Mars.
Yeah, I think it was tomorrow.
Correct. Okay. All right, so for on the bottom where it says decide that whether there's enough information to prove the triangles are congruent, this says side angle side, okay? Stick to just, that's right. I was going to say 5, we continue into the other ones, but that's right. So I would rather you use the name of this than the number. Like theorem 5.5 means nothing outside this book, but every single geometry book uses side angle side. So you want to use the name there, not the number. Yeah, it's like theorem 5.5 because it's the 5th theorem in chapter 5. But that doesn't help like in any other way. So, all right, we're going to do a KimCat. Let's see.